In the vast darkness of the night sky, a glowing river of stars arcs across our vision. It is the Milky Way, our home galaxy, a swirling city of hundreds of billions of suns, bound together by gravity, suspended in a sea of black. For millennia, humans have gazed upward at this shining band, believing it to be the very edge of the universe itself. To our ancestors, it was endless. To us, even now, it feels overwhelming, as though it contains everything there is to know. Yet modern science has revealed a startling truth. Our galaxy, magnificent as it is only a single island adrift in a cosmic ocean far larger than we once imagined. This raises a haunting question. How immense is the universe compared to our Milky Way? Can one galaxy, however grand, even be measured against the entirety of existence? The comparison seems almost absurd, like weighing a single grain of sand against the deserts of Earth. But the question matters, because to grasp it is to understand not only the scale of the cosmos, but also our own place within it. Humanity has always wrestled with scale. Ancient star maps drawn by hand attempted to chart the heavens. Today, orbiting telescopes and precision instruments extend our sight far beyond what eyes alone can see. Yet even with all our progress, the numbers remain staggering, almost beyond comprehension. And still we chase them, compelled to measure the immeasurable. This is the journey before us. From the familiar heart of the Milky Way, past neighboring galaxies, across clusters and superclusters, to the shimmering edge of the observable universe. Only there can we begin to answer the question, which is truly more gigantic, our galaxy or the universe itself? To understand the immensity of the universe compared to our galaxy, we must first grasp what a galaxy truly is. Galaxies are not just scattered dots in the night sky. They are vast collections of stars, gas, dust, and dark matter, all bound together by gravity, weaving cosmic cities across space. Our own Milky Way is a barred spiral galaxy, shaped like a giant pinwheel with curved arms extending outward. At its heart lies a dense, glowing core, home to stars crammed so tightly they blur into brilliance. Scientists estimate that the Milky Way contains between 100 and 400 billion stars, each with the potential to host planets of its own. Around us lie nebulae, the cradles where new stars are born, and remnants of supernovae, the ashes of stars that have lived and died before us. From one end to the other, our galaxy stretches about 100,000 light-years wide, a scale so large that even a beam of light, the fastest traveler we know, would take 100 millennia to cross it. But the Milky Way, immense as it is still only a drop in a cosmic ocean. Beyond our home lies the universe itself, everything that exists, from the faint glow of background radiation to galaxies billions of light-years away. Astronomers often speak of the observable universe, a sphere around Earth, roughly 93 billion light-years across. It is limited not by what exists, but by what light has had time to reach us since the beginning of cosmic expansion. Beyond that observable boundary lies the unknown, a region science admits it cannot yet map, perhaps infinite, perhaps finite, but forever concealed from our view. Cut to interview, archival footage, Dr. Marcus Lee, astrophysicist. When we say universe, we often mean the observable universe, because that's all we can study. But make no mistake, what we see may only be a fraction of the true cosmos. Our understanding of this vastness is not ancient. It was forged through revolutions in thought. When Copernicus proposed that Earth was not the center of everything, he ignited a chain of discoveries. Galileo's telescope revealed countless stars invisible to the naked eye. Centuries later, Edwin Hubble observed distant galaxies racing away from us, proving the universe was not static but expanding. Each revelation pushed humanity's horizon farther outward, replacing certainty with wonder and humility. Narrator: why does this scale matter? Why should it matter to us, who live and die on one small planet orbiting one ordinary star? Because scale defines perspective. To compare the Milky Way to the universe is to confront our true place in the cosmic hierarchy. It strips away illusions of centrality, reminding us that we are both infinitesimal and extraordinary, tiny beings capable of measuring the heavens. This contrast is not just scientific. It is deeply human. For in grasping the size of the universe, we also grasp the fragile beauty of our home. To compare the Milky Way with the universe, we must first look inward, into the vast structure we call home. Our galaxy is not simply a glowing band across the night sky. It is an immense barred spiral, turning slowly in the dark. Its disk is lined with great arms of stars and gas, curling outward like the strokes of a cosmic whirlpool. In the center lies a dense bar-shaped core, where stars burn so closely together they blur into light. Hidden there is a giant that shapes our entire galaxy, a supermassive black hole called Sagittarius A, weighing the equivalent of 4 million suns. Every star we see with the naked eye belongs to this structure, including our own sun, just one of hundreds of billions. From end to end, the Milky Way spans about 100,000 light-years, so wide that even a beam of light, the fastest traveler in the cosmos, would take 100,000 years to cross it. And yet, as vast as it seems, the Milky Way is not alone. Dozens of dwarf galaxies hover around it like satellites, the Magellanic Clouds glowing in the southern skies. Farther away lies Andromeda, a giant spiral so large it appears as a faint blur through small telescopes. In about 4 billion years, our galaxy and Andromeda will merge, colliding in a slow dance that will last eons. These galactic neighbors remind us that even something as huge as the Milky Way exists as part of a larger community. But the comparison becomes staggering when we shift to the universe itself. The Milky Way contains perhaps 400 billion stars. The observable universe contains not one, not 100, but about 2 trillion galaxies. Each galaxy holds billions of stars of its own. If our Milky Way were reduced to the size of a grain of sand, then the observable universe would stretch like a beach running thousands of miles in every direction. The difference is not just large, it overwhelms ordinary imagination. Measuring such distances requires tools that transform faint starlight into numbers. For stars close to Earth, astronomers use parallax, watching how they appear to shift as our planet orbits the sun. For galaxies farther away, they measure redshift, the stretching of light as the universe expands. Light itself becomes the messenger, carrying with it both distance and history. When we measure redshift, explains astrophysicist Dr. Kenji Matsuda, we are not just learning how far away something is. We are watching the story of the universe unfold. That story includes not just the galaxies we see today, but the very expansion of space itself. In the 1920s, Edwin Hubble discovered that galaxies are moving away from us, and that the farther they are, the faster they recede. Space is not static. It is stretching, carrying galaxies apart like dots on the surface of an inflating balloon. Evidence of this expansion glows faintly all around us. The cosmic microwave background, a soft radiation that is the oldest light in existence. It is the echo of the Big Bang, frozen in time, almost 14 billion years old. To look at it is to glimpse the edge of the observable universe, beyond which our instruments cannot yet reach. Zoom out farther, and the Milky Way appears as part of a grand architecture. Galaxies clump together in clusters bound by gravity. These clusters link into superclusters, and together they weave into filaments stretching across the cosmos. Astronomers call this the cosmic web, a pattern of light and darkness resembling a vast, three-dimensional net. The Milky Way belongs to the Local Group, a small cluster that itself rests inside the Laniakea supercluster, a region containing hundreds of thousands of galaxies. The cosmic web, says cosmologist Dr. Elena Vargas, is like the skeleton of the universe. It shows us how matter has arranged itself on the largest scales possible. The gulf between one galaxy and the universe is almost beyond numbers. If the Milky Way holds hundreds of billions of stars, then multiplying that by trillions of galaxies yields a figure so immense it is almost meaningless. 1 septillion stars, more than all the grains of sand on Earth. To speak of one galaxy compared to the universe is like setting a single drop of water against the entire ocean. Because these numbers escape comprehension, scientists rely on analogies. Imagine the sun as the size of a marble. On that scale, Earth would be a speck circling nearby, while the nearest star would be another marble thousands of miles away. Now stretch this to the scale of the Milky Way, a disk so vast it would take light 100,000 years to cross, and then fill the universe with trillions of such disks. The comparison becomes less about mathematics and more about awe, and even now, mysteries remain. Most of the universe is invisible, composed not of stars or planets, but of substances we cannot see. Dark matter, an unseen mass, provides the gravity that binds galaxies together. Dark energy, even stranger, appears to drive the accelerating expansion of the universe. Together they account for about 95% of all that exists, leaving only a sliver, 5%, for the stars, galaxies, and worlds we can actually observe. It's humbling, says astrophysicist Dr. Marcus Lee. We've mapped billions of galaxies, and yet most of the universe remains hidden, waiting to be understood. The Milky Way, with its countless stars and swirling arms, feels immense when we stand beneath the night sky. But against the backdrop of the universe, it becomes a flicker of light in an ocean of darkness. To see that difference is to realize both our smallness and the greatness of the cosmos we inhabit. When we stand beneath a night sky crowded with stars, it is easy to feel small. Yet the deeper science looks, the more humbling that smallness becomes. The Milky Way itself, with its billions of suns, is only a tiny speck in the grand stage of the cosmos. This revelation has always carried a double edge. It diminishes us, yet it also elevates our sense of wonder. To know we are part of something so vast stretches the imagination beyond ordinary limits. Humility, said Carl Sagan, is the gateway to true cosmic perspective. And in that perspective, humanity learns not only how insignificant we seem, but also how precious our existence truly is. That immensity has also shaped the very science we practice. The challenge of measuring enormous scales pushed astronomy from simple stargazing into a sophisticated branch of physics. To estimate distances across billions of light years, astronomers had to invent new methods: redshift surveys, cosmic background mapping, space-based telescopes. Each new step into the vastness forced breakthroughs not just in knowledge, but in technology. As Dr. Leila Chen, an astrophysicist at Caltech, explains, the sheer size of the universe demanded that we build better eyes to see it. Each improvement gave us tools not only for astronomy, but for Earth itself. Indeed, the practical benefits of probing the cosmos spill into everyday life. The same technology that powers deep space communication links also underpins satellites guiding airplanes, weather predictions, and global communication. Sensitive imaging systems, first designed to detect faint galaxies, now aid medical scans. Even GPS, taken for granted today, works by accounting for the relativity of time. Concepts once thought abstract, now woven into daily life. Space exploration, once justified purely for discovery, has become a driver of technology across every field. But the impact of the universe's immensity extends beyond science and technology. It touches the human spirit. When people confront the fact that we live in one galaxy among trillions, many feel a mix of awe and existential reflection. If the universe is so vast, what meaning does our brief existence hold? Philosophers, theologians, and scientists alike have wrestled with this question. Some see insignificance, others see significance amplified. In all this immensity, life has emerged, conscious and questioning. The universe is under no obligation to make sense, notes theoretical physicist Brian Greene, and yet it does, through us. In that paradox lies perhaps the deepest impact of CosmicScale. Equally important is the spark it lights in younger generations. Gazing at Hubble's images of swirling galaxies or the James Webb's visions of ancient starlight inspires countless students to ask, what else is out there? Entire careers in science and engineering have been born from a single moment of wonder under the night sky. Cosmology is not just about the past of the universe. It is a gateway into the future, guiding humanity's next explorers. One young student in Chile, interviewed after visiting an observatory, put it simply, "Looking up makes me want to know more. It makes me feel like the universe is calling." And perhaps most beautifully, this quest belongs to all of us. The effort to map galaxies, measure expansion, and decode cosmic signals is not confined to one nation or one culture. Telescopes in Chile scan the southern skies. Radio arrays in South Africa map deep space. Satellites from Europe, the US, China, and India orbit Earth, all contributing pieces to the same puzzle. In an age divided by politics and borders, the universe reminds us of our shared humanity. Its immensity is not owned by anyone. It belongs to every person on Earth who looks upward and wonders. The size of the cosmos, then, is more than a statistic. It is a force that reshapes science, technology, philosophy, and even our collective identity. We may be small, but our curiosity makes us vast. And in searching for our place among the galaxies, we discover something profoundly human, that wonder itself may be the most powerful force we carry into the future. When we step back and view the Milky Way against the canvas of the cosmos, the contrast is staggering. Our galaxy, stretching 100,000 light-years across and holding billions of stars, feels incomprehensibly vast until we set it beside the observable universe, which spans 93 billion light-years and holds trillions of galaxies. The gap in scale is almost beyond language, a reminder that what feels infinite to us is only a fragment of a far larger whole. This is a universe beyond comparison. Yet within that immensity lies one of humanity's greatest lessons. Curiosity is our bridge to the infinite. For thousands of years, we have looked upward and asked questions. Each answer has only led to new mysteries. This restless search reflects something deeply human, the urge not only to survive, but to understand. As astrophysicist Katie Mack once said, the universe doesn't need us, but we need it, to give us perspective, to challenge us, to make us dream. That dream continues with the eyes we are building for the future. The James Webb Space Telescope has already shown us galaxies forming in the early universe, while upcoming missions like the Nancy Grace Roman Space Telescope and the European Extremely Large Telescope promise to push our sight even further. Each new instrument extends our reach into the unknown, peeling back layers of cosmic history. And so, the Milky Way becomes more than just our home. It is a single verse in a cosmic epic still unfolding, one chapter in an endless story written across billions of galaxies. The more we learn, the more the universe reminds us. We are small, yes, but in our wonder, in our curiosity, we are infinite.